Okay, so let's go. Let me see, back to speaker view, and let me see who I have. I have one hand here. Someone has their hand up, and of course, Detlef does. Detlef, would you like to ask your question, sir?
Yes, it was the hand clapping for for the presentation.
Oh yeah, and please turn. Yeah, please turn your camera on, sir.
Yes, just a moment.
Thank you.
Yes, my question is, which theories do you follow, or do you think the researchers follow doing their experiments? I asking this with background because I'm researching in Kaluza 5D relativity theory, and it has opportunities for a variable gravitational constant and varying rest mass and inertia. So what theories else are there? Perhaps I know you are on the experimental side, but
I try to keep to the experimental side. I try to stick to, well, relatively simple physics. I haven't tried to go into the theory, into sort of more modern theory. It's really looking at practical things, which again, analogies with electromagnetism, things which would permit us to do something experimentally to give us something. My background is really not in theoretical physics. It's my degree was mainly fairly practical, applied, what you would now call applied physics, and so I tend to stick to the accepted relativity and quantum mechanics, but obviously the others are interesting. So yeah, things which are provable in experiment, I guess.
Yeah. You showed the Maxwell equations in your presentation, and it's in the midst of the 19th century, developed by Maxwell. And in the 19th century, there was done a lot of math, beginning from Gauss over Maxwell, Minkowski, and Ricci, Kurbowski, Levita, Civilita, and if you put all the mass together, it could have been seen that the electromagnetic energy stress tensor is can be generated by the curvature tensor of 5 dimensions. When you render the 4D relativity with the electromagnetic potentials. So this could have been a hint that curvature is important, and also for gravity. So if Einstein hadn't found it, this hint could be also to be successful.
Yes, yeah. I mean, I really only introduced the equations as an analogy, so that to show that people have in the past tried to adapt it, that heavy side, and so on, to see if there is something useful that we could get, that we could apply to gravity.
It's the Thirring lens effect.
Yes. Yeah.
Okay.
Okay. Well, thank you, Detlef. Okay, so let me go to Mark Sokol next, sir.
Okay, Rob, first of all, thank you very much for that presentation. This is probably one of the first presentations on APEC that I'll have to rewatch, because it was just like an information overload. Like even in the chat, I was getting tons of stuff hitting me from all directions. You started talking about bismuth and its relationship to element 115. This is something that I noticed earlier on. And I pointed it out a couple of times. It's a very interesting correlation. Bismuth being the strongest diamagnetic metal or naturally found substance other than pyrolytic graphite or superconductors. You mentioned that spinning experiment with bismuth. What was the results on that?
The results from Tajmar.
Okay.
That's he did initially have a positive result, but when he isolated everything to avoid vibrational effects, it disappeared.
Are you aware? This is something that Wayne Ojala or Fail Forward Research actually pointed out. Bismuth is a very interesting metal because it's both diamagnetic and it's also a poor conductor of electricity when it's formed in its crystalline form. But when you manage to get the entire material into one crystal or one, where there's no crystal lines, or if you could do it via vapor deposition, which is something that we're looking into, similar to what they had in that terahertz waveguide thing from Linda Moulton Howe, it actually becomes a superconductor. Or very near.
Very near, yeah.
Also, I want to contact you afterward for that waveguide specialist because we do have we need we needed some help with the Alzafon experiment for that.
Yeah, and I have a ton of links which I'll put in the chat, and her website is on there as well. But yeah, I can fill you in on what I know about the situation.
Okay, thank you very much.
Yeah. Okay.
Awesome. Okay, well, thank you, Mark. So let me go next to, you know what, actually, let me go next. I promised him, and now the chat is squirreled. Michael Boyd, sir.
Can you hear me?
Yeah.
Yes.
So, Rob, my question I was observing that experiment in the vacuum chamber with the spinning disc, and I was noticing the effects there, and I'm curious about the flatness of the disc. How flat was the disc? You know?
No, unfortunately, no. There have been a lot of people saying that, well, if it's not completely flat, then it could just be knocking the block, as it spins.
Yeah, well, not so much that it would knock the block; it would affect the gravitomagnetic field because it's normal to the surface of the disc, and it's very sensitive to the flatness.
Yeah.
So for example, in your hard drive disk, it's made to a 1 angstrom flatness, and then they rough it up to about 2 or 3 angstroms so you can use it, but it's pretty damn flat. Yeah. So some of those effects could be due to the flatness of the disc itself.
Yeah, I know that he said that I think he told Tim that he was using depositing gold nanoparticles on it. So I guess he would start from a very flat surface, but maybe Tim knows.
Did he have the gold nanoparticles uniformly on the surface, or were there in patches?
I think he put them in kind of bands, radially out, so you have concentric circles. I think that was from his interview.
They were in the circumference. They were in the direction of the circumference of the disc. Is that what you're saying?
Yes. And if I could jump in real quick, Michael, I think I kind of see what you're driving towards. You're asking mostly about like the regularity or granularity, right? And if that's enough to create the bumps and the pits that. And it probably could be, because I'm not sure if, I don't think he was focused on the kind of flat surface you're talking about, right? So my guess is that there's probably a lot of irregularities that could create the effect you're investigating.
Well, the other thing is if he's using a metal, he's depositing a metal, at the edge of where the deposition goes, there's going to be a step to the original surface. What was the disc itself made of? The substrate of that he was depositing the gold film on? Do you know?
I don't remember offhand. Rob might.
Oh yeah, I'm just curious about some of the effects that I was observing. Did he try it outside the vacuum chamber?
I'm not sure.
Because it really has nothing to do with the vacuum.
Yeah, I know in my case, I talked to him over a year ago. I can reach out again. I can reach out to him and see, try and learn more.
Cool. Well, thanks.
Yeah, I imagine he would use it in a vacuum to avoid any accusations that, yes, it's wind effects and that kind of thing.
Well, if he's observing very, very small signals, yeah, I could see why a vacuum would benefit. But if there's something there, it'll show up.
Okay. Okay. Well, thank you, Michael. So let me go next to Wayne with Fail Forward Research.
Hi there.
Hey. There you
Hey,
go.
yeah, Rob, thanks for your presentation. It's just strange how so many things you mentioned are pretty much what I'm going to be talking about later a little. So that's really, really interesting.
Okay. I don't want to take any wind out of your sails.
Yeah, that's awesome. Yeah, I've been doing a lot of fooling around with rotation and superconductors, and I've been making these discs, which are just like I ground up bismuth and put them in resin, or put it in resin, and I've been rotating it and cooling them with liquid nitrogen and seeing if I can see any weight changes and stuff like that. So I'm going to play a video later on with some of those experiments. I didn't really see anything happen with my setup, but it's still interesting to check out and explore. And also, I was thinking with that Podpanov's disc that he was spinning with the gold microstructures on there. If they're like, if you could imagine this being like a nano size tube of gold, and it's being rotated through space, I'm thinking that the tubes, like the very, very thin walls, like if they're just a few atoms thick, that they'll polarize much more easy along the axial direction. So you get a much better polarization effect by rotating if they're just like, if they're nanoscale tubes. That's what I'm thinking.
Wayne, let me focus you in. What questions did you have for Rob though about his presentation? And I should apologize for jumping in, but I want to refocus you on what are some questions that he could answer, I guess, because
I didn't really have a question. That's I just pretty much said all I was going to say. Just
oh no,
some
that's
ideas
okay. That's
and
okay.
comment. But no, I appreciate the information and what he shared a lot. So thank you.
Well, yeah, and I look forward to you presenting later as well too. I think we all do. So
Thanks.
Okay. Well, let me go to Jeremy Reese next, sir.
Hey, Tim. Hey, Rob. Good job. Thank you for that. I have a couple questions from the live chat here. One guy was interested. He wanted to know if you'd ever heard of a 19th century occult physicist named John Keeley.
Yes. Yeah. I don't know much about him, but yeah, there was a Keeley Net website, I think, a few years ago. I don't know if it's still around, but yeah, it was based on his kind of interests. So yeah.
I had one guy wanted to you to speak a little bit more about the mass of a standing wave.
Oh, right. Well, yeah, there's a whole series of papers by Jennison. Where the first one is Jennison and Drinkwater in about 1977, where they model particles. They said, okay, if you can call it whatever you like, but if you have as I understand it, you have the wavelength at the Compton wavelength, so basically the diameter of an electron, you're basically simulating an electron at that point, and so you've got all the by creating a standing wave in a wave, a cavity, a reflective cavity. So it's a closed cavity like the EM drive, but symmetrical. And that if you choose your wavelength correctly, you end up with the properties of whatever particle you're targeting. So it would presumably be just for fundamental particles like the electron. That's the specific example that he gives. So
Interesting. Yeah, thank you for that.
yeah. I mean, actually, Ron Evans, who is in the audience, so he may, because he was actually at that meeting, so he he may have a better understanding of, or a better explanation of all that.
Thank you.
Awesome. Thank you, Jeremy. Let me go to Will. Will, would you like to go, sir?
Yeah, my question here, actually two questions. The first question, I bought the book Project Greenglow, and it was an interesting read. A little light, but it was interesting. I've always wondered, what is the lights coming out of those vehicles? What does that represent?
I think maybe Rod Evans can explain better than I can. But as far as I'm aware, it's just because green is associated with little green men and that kind of thing, that they thought, well, if they were speculating on what a propulsion device might look like, what the out exhaust might look like. So it was a case of artistic license that, oh yeah, we'll call it, we'll say it's green, and you know. I don't think there's no real science behind that. It's just they did a lot of studies about, well, how do we build a vehicle around, okay, assuming that a drive exists, what else do we need to do? So there was a lot of work done by someone called John Allen, who did a lot of work for BA, developing kind of the whole economic commercial structure around assuming, basically all you would have to do then is drop your engine in, and everything else was ready to go. But in terms of what the engine does, no, it was a black box. So it's on the assumption that we have this fantastic anti-gravitational drive. What else do we need to worry about? And so the paintings and drawings came from that.
Yeah, it really wasn't clear in the book either. So
Yeah,
that's why I wanted to ask
yeah.
about that.
Yeah.
So
Yeah,
because
yeah,
I was thinking it was a kind of cyclotronic light source. That's what I was thinking. So.
It could be. As you can see in the, I don't know if you can see in the gallery, Ron Evans has a picture behind him on the wall. I presume that's the original.
Oh, you know, and if I could jump in really quick, in terms of the green glow, I had read, I don't remember what book, that in UFO reports in the 1950s, they had seen, I remember reading about an actual green glow with some of these craft or something. And then there was speculation that it might involve copper, because that was like the discharge frequency for copper. So there was some correlation there they were trying to make. So it could be related to that as well, potentially.
Right. And then my second question is, in this work, what was your role in this work? Because
Well,
I see a lot of everybody else's work, but I'm not sure which part was yours.
Well, yeah, I mean, I as I say, I was more kind of the public face or social media management face. I wasn't. It was a purely voluntary thing. As Ron, I think, explained to me in his presentation, he was even on it part-time. So it was really just me volunteering my spare time to try to get the word out, try to facilitate some discussions, and hopefully, get some cross fertilization of ideas. Now, sometimes that works for you because you have a big name behind you. Is that you see? I have a BA address, email address, and of course, people say, "Well, I don't want to help you because you're a big corporation and you'll take my idea, or you're defense related, so I don't want to deal with you." So it kind of works both ways. And that was always an issue throughout, really.
Yeah.
But no, I didn't really make a technical contribution myself. I would look for things on the internet, what was new, what new things were coming along, what people were working on, and if there was something promising, I would then pass that on to Ron and say, "Oh, this might be worth looking at." Things like the Marcus device, that was one of the biggest disappointment, really, but that was a major one during my time, or our time together at BAE.
And in the end, how did BAE? What was their final reaction in the end? I suppose that they wanted a final report. And so how did that go?
They got one. I know Ron Evans wrote it. So just before he retired, so he summarized everything for them. I mean, as I understand it, I mean, it was all standard physics really, and they BAE were only funding respected, as it were, respected scientists in institutions who were looking at, using known physics, establishment physics, if you like, to go further. So nothing really radical, I think, although maybe Ron has a different point of view. But
Okay,
I think
thank
they were satisfied with the final report. Put it that way. As I say, the problem is that quite a few people left the country. the brain drain is an ongoing issue, particularly after Brexit. That people are leaving for better money elsewhere.
Mm. Okay,
Well,
well, thank you, Will. Let me go to Aidan Schaefer next, sir.
Yeah. Hey, so this is a game of telephone, or a story I got from a coworker up here in Taos, and he was out camping in the hills over by like Angel Fire, and he said like a C-130 flew over, and then as it did this really funny weird U-turn, and its engines turned off, and then it came back over silently without any engines, and there were 2 rows of glowing green tiles underneath it. And I quizzed him. I worked with this guy for a couple of years, or excuse me, several months, and he stayed the same on the story and didn't do any sort of variation on it. So there may be a system that, some type of electrostatic propulsion or something that they can use that emits a glowing green to it. And then I've heard of like, I guess it's more advanced alien propulsion, but like if the saucer is real close to the ground, and then it does that like instant takeoff outward from the planet, it will leave a glowing ring underneath it. So it's evidence of like a scalar wave propulsion system. That's just my commentary from looking for things that glow green and getting some good stories from around the spaceport.
Okay, yeah, and Aidan, did you have any questions specifically for Rob, or
does that? I mean, these glowing green tiles with their. I saw the footage of the thing that was bouncing, and I don't know. I guess just to follow it up, like, I mean, I have a secondhand observation of something that's silent and glows green while it pushes a vehicle along, and I don't know. I'm just food for thought, I guess.
Yeah, I mean, maybe some kind of electrostatics. I know that BAE did some looking at using plasmas for drag reduction, possibly stealth, that kind of thing. But also, it reminds me a little bit of the B2, the speculation about the B2 and using electrostatics to either reduce drag or increase thrust or whatever. So maybe something along those lines.
Awesome, thank you. Okay, well, let me go to Mark next, who has been patiently waiting, sir.
Is that me, Mark Florentino?
Oh, actually, Mark Florentino, sir.
Hello. Can you hear me?
Hello. Yes.
Yeah, great. I really enjoyed your presentation, and there's a lot of things, a lot of the topics that you touched on really are close to me and the work that I've been working. What I wanted to know is, what is your favorite anti-gravity theoretical model?
Good question. Yeah, I'm not really sure I have a model as such. There's things which would be nice if they worked. For example, the forward torus, if there was some means of increasing the the effect of gravity on that, or reducing the effect rather, that would be really useful. It does. I mean, there seems to be a connection. This is part of what I try to do, is to find analogies and connections. There seems to be a lot of connections with rotating structures, with aligning nuclei, torsion, whether this torsion is connected, or it depends how you define torsion, I guess. And that all seems to, I don't know, mean something.
Yes,
I'm not
yes.
quite sure what.
Excellent. Thank you.
Okay. Well, and thank you as well, Mark. Okay, Mr. Sokol.
Yeah, I just want to make a correction before talking about bismuth. It was actually Jeremiah Pop who brought that to my attention. And there's also a patent over here that I just posted in the chat for that talks about the bismuth. As it gets thinner and thinner, you can actually get closer to superconductivity. And about the thickness of the layers that we saw in the bismuth, magnesium, zinc sample from Lindemann and Howe, that is about the point where it becomes superconducting. And in this patent, they talk about making wires superconducting at room temperature, normal pressure, just using bismuth, very thin bismuth.
Yeah, that kind of reminds me of the paper that was partly sponsored by Greenglow working on bismuth. It was I think it was a strip of bismuth. They were looking at inducing a thermal gradient in a perpendicular to the thermomagnetic gradient or something. So I don't think it was superconductive, but it was looking at thermal properties and thermomagnetism. So
Also,
there's a connection.
Yeah, another interesting thing about bismuth is it's kind of rare. It's 2 times more common than gold, and there's a limited supply, and there's almost no use for it other than Pepto-Bismol. So if there's any connection between anti-gravity craft, the skin, if there's any need for bismuth inside these spacecraft, expect the price of bismuth to go up from $5 a pound to $60,000 or $100,000 a pound. Similar, it would be like buying Bitcoin 10 years ago.
So you're saying that you can choose between heartburn and gravity. Those are your choices.
Well, it's not even that great at Pepto-Bismol.
Well, actually, if I could jump in, Rob, I would like to ask. You'd mentioned Ron Evans' new book, right?
Yes.
Would you be open to bringing that up on a screen share? And I think we have Ron with us. If he'd be open to joining in. I'm not sure if he's set up with his mic and all that.
I think it's not actually out yet, but there is a page on its publisher's website. But it's available for pre-order on Amazon. I'll put a link in later, but it's not out until the 28th of July. It's I think it's Gravitomagnetism, I think is the title.
So the focus of this book then is more scientific and less about Greenglow as a project, right?
I think so. Yeah, you might want to bring Ron in if he wants to.
Sure. Yeah, I can ask him to. If you're open to it, this is your Q&A session, sir.
Yeah, no, I'm fine because there's a lot of overlap.
Oh, and there's Ron. Okay.
Yeah.
Ron, are you with us?
Hello. Can you hear me or not? Yeah.
Yeah. Could you tell us a little bit about the book?
The book, it is called Gravitomagnetism. I don't know really where to start. It's I was asked to do a presentation, which I started to do for a club in London. And after I'd been going for a bit, I realized what I was doing was getting all my ideas together and sorting them out. And it was really the beginning of another book. It's taken me a long time to do. And text-wise, there have been so many errors. Anyway, so it's coming out fairly shortly. I've done most of the proofreading now. My interest is in gravitomagnetism itself. If you go back to Newton's time, when we talk about doing mechanics these days, we use Newton's mathematics and we use the kinetic energy, and we don't use gravitomagnetism at all. And the point is, Leibniz introduced what he called vis viva, which was, in fact, kinetic energy. And we always think of it as being associated with whatever the mass is that's moving along with a velocity. If you look in terms of gravitomagnetism, the outside of the mass, gravitomagnetic permeability is so small, it doesn't exist. It's inside the mass. So if I've got a sort of a hint I would like to say to everybody is, we need to do experiments on Earth somehow looking for a gravitomagnetic effect. Until we can get our hands on it down here on Earth and start poking it, we're not going to get anywhere. Okay, they are all analogues and all models are wrong, we know that. But these analogues have given us a clue and they've not been explored fully. In the book, I have given some possible ideas. Whether they're sensible or not, I don't know. At the moment, I'm spending quite some time going back to the thermodynamics, because in terms of an analog, thermodynamics has an exact analog with gravity. It's amazing. It probably even explains thermoelectricity, but we need experiments. Experiments are the way forward, not the model. The model's the clue, but could lead us up the garden path if we're not careful. So we do need the experiments. That was why I was very keen on Faraday's experiment, repeating that and using fiber optics to try and use the Faraday effect. So if I can just jump now completely to go back to the Greenglow, at the time, as Rob told you, we were looking at drag reduction and stealth effects using plasmas. And we had some work being done by a company in Oxford, and they had a lovely pink plasma, and it was very stable, very good, an atmospheric plasma. But we couldn't call it pink glow, could we? It didn't sound right for our model aeroplane. So we went for green glow, and you are right to point out that it's a copper effect. So that's what happened. Was we showed the director what we'd got, which was just a vertical lifting aeroplane with no colors at all. And he said, I'm going to show that at a university. It looks so boring. Put some green rays on it and we'll say they're anti-gravity rays. So I hope that explains where that came from.
Yes, absolutely. Thank you, Ron. I appreciate that. I was just double checking with Rob. We were trying, he has, in fact, let me see if, oh, he's going into screen sharing.
Just sharing it now.
Ah, there we go.
So,
okay. I don't know whether you can see the picture behind me.
Yeah, I think you showed this to us during your presentation, actually. I wasn't sure if this was the same.
There it is, there up on the wall.
It's out of stock. Where can we buy it?
No, it doesn't come out until July, I think.
The art on the front reminds me of Tintin. Do you remember the old Tintin? Yeah.
I had the same thought, yeah.
Oh, look at Wayne Ojala. He looks like Tintin.
I'm not going to say anything to you, Tim, but you're actually right.
Yeah. So the only thing that's missing is you'd see Snowy in a spacesuit.
Ja. Ich habe ein Buch, Ersten Schritte auf dem Mond. Very similar picture.
Bob, is this going to be available on Amazon here in the US?
Oh, yes.
Yes, it should be. It was there the other day, I think, as a pre-order, but it's been taken off again. So I suppose until we're closer to the release date, it's not going to be a stable thing. As soon as it is available, I'll pass it on to everyone.
Now, have either of you gentlemen done more? I mean, I know that the Greenglow project has ended, but still, this was it seems like this was kind of the big project for the UK, you know, this was, and there was a lot of pride involved. And, you know, I mean, is this something where you guys are doing more media about Greenglow and kind of the legacy that it's created, or are things kind of winding down there?
Well, I'm not winding down at the moment. I don't know about you, Rob. Are you winding down?
I'd like to be able to wind down. No, but where I am, no, there's not much going on here either. Although I have been recently been put in touch with Jean-Francois Geneste, so I'll find out what he's doing. He presented recently as well. And
whatever happened to Graham Ennis? You were quite close to Graham Ennis, weren't you?
He's still there. He's still in Brighton, complaining to the council about things generally, as far as I can tell.
Right. Because he ran a very interesting conference.
Yes, yeah.
Which you didn't mention.
I wasn't able to go. Oh, well, I didn't go. I wasn't able to go, unfortunately.
Right.
No, but actually, I forgot to mention that we did have the Novel Physics Club, which again it didn't really take off, but there was a session in London with Roger Penrose, who
Yes.
gave a lecture. That was very interesting.
Oh yes, we had Roger. We had several people quite well known. John Allen, Professor Allen, wrote a book, The Future of Aeronautics, Hutchinson Press, I think it was, in 1970. And he had a chapter in there on gravity. And the director in charge in those days of Kingston, where the Harrier was made, told him to take it out. He didn't want the company associated with it. So he had to take it out. Gravity, anti-gravity, doesn't go down well with management in big airplane companies.
Yeah.
So we had to be careful, even, you know, at Wharton.
I mean,
And it was never a big project, Tim. It was always small. And as Rob has told you, it was always part-time. All of us we're all interested in it, but it was part-time.
Yeah. I think the big concentration was on aerodynamics and that kind of thing. It wasn't, they're more concerned with building airframes and
Yes.
efficiency.
Well, that's where the
and
money came from.
aerodynamics.
That's where my pension comes from.
Yes. Yeah, mine too. Well, part of
Yeah.
mine.
Yes.
But
it was interesting
yeah.
when the BBC wanted to go to Wharton. A lot of the engineers at Wharton, when they made the film, the BBC film, a lot of the engineers at Wharton were keen, and we had a meeting at Wharton. I've got to be careful what I say, but head office stepped in and said, no way, we don't want you there again. So I don't, you know, I'm on the outside now, so I don't know what they're doing.
No. Well, at the time when I was saying about running a mailing list, I was also running an internal BAE mailing list as well. And we had about 20 or 30 people there. So there was a lot of in-house interest. Again, there's no money, but there were a lot of interested people.
Yeah.
I think the problem is that the propulsion side was they would farm that out to Rolls-Royce. They would say, well, that's nothing to do with us. That's Rolls-Royce's business. We're just building airframes and improving aerodynamics. We're not concerned with propulsion.
Can I express my thanks to you for keeping me informed? You're good.
I do my best. So yeah, I hope I didn't say anything out of turn in the presentation.
No, it's good.
I think it was all fairly unclassified stuff as far as I know.
Greenglow is unclassified, totally unclassified. The work that was very much, well, some of it was related, was stealth, which is classified, but there was no gravity involved with stealth.
Yeah, well, and I thank both of you for your presentations, and it was wonderful to hear Rob's as well. And Rob, you covered a lot of I would say diverse technologies, right? So more than just the Greenglow. Greenglow was maybe more focused, I guess.
Yes, yeah.
Yeah.
I mean, I used it as a kind of a springboard for other things, so that it would attract the attention of people who are in related activities. So yeah.
Now, do you have any books? Do you have anything? And you don't have a website, right? But
well, I have a blog, but I haven't updated it for a very long time.
Oh.
It's European Anti-Gravity, which is named in tribute to you, not as a competition. It was a tribute to your to your site. I can put a link in the chat if anybody's interested, but yeah.
Okay. Well, thank you. Yeah. Yeah. Well, let me see. So I think Will had another question, and again, I should apologize.
Real quick here.
Yeah.
Two questions actually. I have the Greenglow here on my iPad. Will we have this new book on iPad available?
It will be an ebook.
Okay.
Yes.
So that's good. And then the second thing is, do you think that your work in Greenglow is why Boeing afterwards did their thing?
No, they were doing it at the same time.
Oh, were you at the same time?
They were doing it at the same time. Yes.
But did your project influence them, or was BAE and Boeing kind of doing it together?
No, I'm just trying to remember the man's name. We certainly talked to Boeing, as well as Gary Stevenson, of course, because he was at Boeing at that time. But we never worked together as a company.
Yeah, so his name is Jamie Childress.
You're right. Yes.
Right.
Yeah.
He's actually
And,
David Hatcher Childress' brother.
Really?
right. You got to wonder what happened at their family dinner table to cause them all to be interested in this.
David's brother.
Yeah, he
And
was.
I believe
Yeah,
Hunter as well.
Well, the one is on ancient aliens all the time.
Right. Yeah. Yeah. So all of the family members are interested in it for some reason.
Yeah, and Jamie was over at Phantom Works. I had lunch with him once or twice, but Gary knew him much better.
Right. Yeah. I've worked with him, and that's about all I can say about that.
The last thing I saw from Jamie was some sort of disinfectant for toilets on aircraft. He had a patent for an ultraviolet disinfectant, which I thought was a little bit odd.
Oh, you mean for COVID, right? You mean
Well, I think it was pre-COVID. It's a patent that was, because I again, for the presentation, I went looking to see what had happened to some of these people, and the last thing I saw from him was a patent to disinfect aircraft toilets.
Oh.
So I thought, this is a bit different from what I was expecting.
Okay. So that was, a little bit more specialized. Yeah.
Yeah.
I'd heard from COVID, someone had sent me the results of a study, and I don't remember what basically they did a study on COVID in aircraft, especially the air conditioning ducts. And this was several months ago, so maybe they found a solution, but they'd said that there was basically no way to get it out. They'd said that, I mean, they didn't have any way to disinfect those aircraft completely. So.
No, I know that I've worked on things like A350 and A380, and some of their systems, they blend outside air. So you have a certain proportion of outside air, which you can maybe adjust a little bit. So it's sort of 50, 60%, but there's always an element of the internal air, that you can't really shift. So yeah, it's better, but it's not great.
Yeah. Well, let me see. So let me see who else has questions for Rob. And Rob, I certainly appreciate your time with us.
No problem. I think Ron Keeter's been keen to to speak.
Oh, okay. And then we have Sam Thompson. Well, let me go. Yeah, let me go to Sam first. He just put his hand up, and then I'll go to Rob after that.
Hey, Rob, excellent presentation. How much does it cost to do research in electrogravito-magnetic propulsion? It's a mouthful. Like, you're not talking about salaries, like just getting the equipment you need to.
I'm probably not the best person to ask. It might be like someone like Mark Sokol, because I know they've been doing this kind of thing, doing lots of experiments. So I guess it depends what you want to do. I suppose it could be a few $100s to a few thousand, depending on what kind of materials you're using and how far you want to go with it. Maybe I'd say if Mark wants to say, he might be able to.
Yeah, I mean, a few $1,000s seems pretty cheap for figuring this out. I feel like if you all start a GoFundMe and ask people to like chip in,
I think they've got a GoFundMe. Actually,
throw money at you. Yeah.
Oh yeah, it's not really all about the money. I mean, I've seen some people who were putting together a website to get funding from NASA to do this experiment, and I went through his website, and I noticed that you could put this all together for less than $200, and at the amount of time he spent building the website, he could have worked minimum wage at McDonald's and made enough money to cover his entire experiment that he was trying to get funding for. It really has to do with your knowledge, your abilities, and your willingness to, work on the fly. I mean, there's people like Jeremiah and Wayne who like literally can take things out of the garbage and turn them into these, high voltage power supplies. And, it's crazy. The kind of stuff that we're throwing away nowadays, it can be turned into experiments. Like a lot of the experiments that Jeremiah does are using old hard drive parts, like pulled out of the garbage. It's not about money. It's about knowledge.
I think it'd be great if APEC had an online forum where you all just pitched in your ideas and talked about like collectively what it would take in a group experiment to do something like that. Because I feel like a lot of people would want to fund you guys if you set up a plan people could see.
You know, and we do. So yeah, I mean, that's one of the reasons that we do lab updates, right? And because that's, you know, Mark, not just Mark, but Mark and Jeremiah and Wayne and, you know, Todd, they're all doing hands-on experimental work. And so that way they can kind of provide updates and let everybody know and share, you know, here's what we think may work. But then also Jeremy Reese on the Alien Scientist channel, he covers a lot of this material all week long. And so he's got, look, I don't know if you visited his channel or not, but if you just Google Alien Scientist on YouTube, right? And he's got like 2 or 3 times a week new stuff, so.
But in addition to that, like if there was a roadmap too, to know like where you plan to go, like I feel like, you know, the more knowledge you can put on the website, the better.
Yeah. Okay. Well, thank you. So let me go to Ron Kita next, sir.
Unmute. Hello.
Yep. You're there, Ron.
Okay. Is Uncle Slacky here? Is Uncle Slacky
Yes.
in the audience?
Yes, indeed. Yes, yes.
Okay, Uncle Slacky. Yeah. Anyways, yeah, one of my favorite materials, my rants here, is it was invented in Britain. There's no U.S. patent on it. There may have been a U.S. patent almost during World War II. The bismuth magnet, the combination of bismuth and not magnesium, but manganese. Bismuth manganese bismuth is bismuth manganese alloy. It was invented in Britain, and I wondered if you ever have you ever heard of it? Looked into it? It's across the pond. It wasn't invented in Chambersburg, Pennsylvania.
No, I've not heard of it. No, maybe Ron has.
Because I was a friend of Boyd Bushman, and basically it's patterned metal technology of just simply taking nano powdered bismuth and manganese and isostatically pressing them and then polarizing, magnetizing them. And what happened is I looked at in terms of the patenting of it and so forth, I think World War II may have held it up, but there is a UK patent on it. And then I looked for a US patent, and then I found the UK, which was good enough. But I told Boyd, I said, you're dropping neodymium magnets, which are dangerous. I said, make a bismuth, a diamagnetic magnet, which is just completely foreign to what we know. It's just in terms of its crystallization properties, it crystallizes with the correct electrons. And so I told him about it. I said, you might find things are even better. And so, but Boyd and I, we talked about a lot of things. The other thing is there's a book. It's called UFOs and Diamagnetism. It's out of print for years. I read it probably 30 years ago. And I read through it. I was hoping to find what to do with bismuth, but the author is Burt, B-U-R-T. And so in terms of, since this is your field, and also I was a friend of Henry Wallace. When he was fired from General Electric for working on anti-gravity. And because his friend says, well, he says, Wallace, I looked at Wallace, Henry Wallace made a lot of money during the energy conservation days. He could save a lot of money for GE. I looked at his patents. He was a cash cow for them. His experiments had to get cleared through Princeton, and nobody liked it at Princeton, and they fired him because his friends told him, stop doing anti-gravity, they will fire you. And the thing they fire you. Then the last thing was, oh yeah, with Wallace, if you look at Wallace's patent diagrams, what he used in his experiments was an air-driven gyroscope. What was used in there was an air-driven gyroscope thing. I don't know if he ever made anything out of bismuth or anything. I never heard of anything odd, but yeah, I interviewed for GE down at the reentry systems in Philadelphia, And I thought reenters was bringing back astronauts.
Yeah, yeah.
You ever hear of MERV? It was the MERV program, multiple independent reentry vehicles. I was being interviewed. I thought, oh, I will work bringing back astronauts. But anyhow, yeah, the Wallace Patton is a brass gyro, and I'm not quite sure. And the other thing was what Mark was talking about was the Burgoyne patent on the room temperature or ambient temperature superconductors. Yeah, so that's all I have. It's my rant. And so I got your email address.
Yeah.
Anything else?
It's interesting because of course in the 1950s everybody was studying gravity. It was all over. It was in the papers, and all the big companies were studying it, and then it just went silent. And then, as you say, it's career suicide to research it.
It's about the shareholders. If the shareholders hear anything tied to, one of my best contacts, 3M companies. 3M companies makes a lot of electrostatic materials. And Dr. George Buckley, he's now over in the UK. Buckley was head of 3M Corporation, and he liked electrets and gravity. And then he handed me off, I thought was to a secretary, but it wasn't a secretary. She had a PhD, and I treated her like a secretary. And she says, a 3M company cannot have any connection to UFOs.
But isn't there that famous force field that was generated by, that was 3M plastic or something?
Oh yeah, that was the
generated the force field.
Yeah, that was intriguing. In terms of something being real there are several good explanations for it. In terms of where people should go. People should go there. It's just in terms of having the time to go there, it's, you can only do so much. So you're in the south of France.
Yes, yeah.
Okay.
It's pretty hot. It's pretty hot today, which is yeah.
What was it?
Yeah, about 20. Well, 80. It's in the mid 80s Fahrenheit.
Yeah, because I worked in Nice for a while, and I was paid by Germans, which was
yes, yeah.
And I went to Cap Antibes.
Yeah, it's a European corporation for you.
Yeah. Okay, good yakking with you.
Yeah, thank you. Thanks.
Okay, thanks again, Ron. Let me see. So, Matthias was asking, but he might have been asking about something else. He was asking if it went silent because it had positive results. I think he might have been asking about something else. Oh, SAIC, I believe. So never mind. That's chat questions. Who else has questions for Rob? Because we've got about 10 minutes left. Okay. Anybody else have questions for Rob? Let me see. Let me scroll through chat.
Yes, I have one more.
Oh, yeah, go ahead, Sam.
Why hasn't anyone been able to replicate, I'm probably going to butcher his name, but Polikoff's experiments? Have they been replicated?
There've been lots of attempts. I don't think anyone's ever done it the same way he did. This is his objection usually to people, is that they've tried to either rotate it mechanically, they haven't used the magnetic fields to actually make it spin. It seems to be quite a difficult experiment to get right. You have to have a disc that's the right size, so about 10 or 12 inches across, which is apparently is quite difficult to manufacture something out of YBCO that will stay together. If you spin it too fast, it'll shatter. I think was it Tony Robinson? I think he mentioned that when they did it, that's the sort of trouble they had. So I think it's a difficult experiment to get right, and there's lots of ways it can go wrong, or not go wrong, but not give you any results. So that's why it's always been a kind of debatable about whether it really worked or not.
Okay, and then let me see. Michael had another question as well.
I'm curious. So in my experiments, I found two kinds of fields. I found one that was a hyperbolic or a pushy field, And then I had one that was parabolic, which pulled. And I'm curious if any of the experiments that you've seen with gravitomagnetism showed both polarities of gravitomagnetism. Any other experiments, I guess I should say.
Not that I'm aware of. I don't know if Ron may have seen something along those lines, but
So the one we were watching where the spinning disk and the object was flapping like this, that was a pushy field, correct?
Yes, yeah, presumably.
That was
I don't know the full details. Yeah.
It was anti-gravitational. It wasn't gravitational. It wasn't pulling. It was pushing.
Yes, yeah, because it worked in both the vertical and horizontal. So it's, yeah.
Okay, that's cool. Thank you.
I think Ning Lee, Michael, probably, because she called it AC gravity.
Oh, good.
So that would be the push and the pull. And I think that was what she was referring to when she was talking about AC gravity, if I remember right.
Oh. Interesting.
Yeah. Okay. Well, we've got about,
get her.
Yeah. I have, in fact, someone just did a thing on her online. I haven't heard anything from her. There were rumors, lots of rumors. She went back to China. Maybe she passed away from cancer. I think that was one of the rumors. Other people have said that she's working in the private sector and she's still in Huntsville, I think. So it's hard to tell. Okay. Let me see. HT Avarice had a question. He was wondering, Rob, what's your evaluation on gyroscopes for propulsion?
Good question. I think the jury's still out, probably. As I mentioned, there's a guy in Portugal who's working on it, so he seems to have positive results, but he is very short of money, so he's looking for funding really to pursue it. He seems to have a kind of a theoretical basis, he thinks, for it. So yeah, this is it's Hayasaka, who you essentially rotate a gyroscope in one direction and it appears to lose weight, but if you spin it the other way, nothing happens. It doesn't lose or gain. So although it's been that's been contested over the years as well. There've been people who've shown that it didn't happen, and others who say it do. So again, I think the jury's out still.
Okay. Awesome. Well, we have just a few minutes left. So what we could do is if you guys want to take a short break after, if we don't have any more questions. Actually, there's actually Nuno does.
Nuno is here with us. He's
okay.
Got his hand up.
Yeah.
Hello.
Nuno, go ahead, sir.
So good afternoon. This is Nuno from Portugal. Yes, for my PhD, I decided to try to study this effect reported in physical review letters, and I had local support from professors at university and technicians. I got some positive results, but still I am in the process of perfectioning the experiment. It's not public, and I was not granted PhD scholarship, so it was right managing things by my own. And what I can say is that the theoretical framework that I've studied was developed by Professor Hayasaka itself in Tohoku University, and it's based on a simple theorem of the RAM cohomology. This term is a little bit strange for those who are not scientists. It's just a branch of topology. So topology was invented as a mathematical framework for curved surfaces or curved spaces. And in each topology, topology is related to a space and to a nil operator in this space. Yes, and in function of the nil operator, we give a name to this topology. So the RAM cohomology is the topology that uses the external differential operator. Yes, so this study I have conducted is still under the process of confirming a little and trying to study the origin of such a little weight reduction in the order of milligrams, who is not originated in Tohoku University, but in Russia, from a scientist in Russia, which is Nikolai Kozyrev, who conducted in the 60s these experiments in Russia. Yes. Also in this experiment, there was many negative results from many researchers, and I don't understand what happened that nobody at the time went to Tohoku University to visit the experiment, or there was some difficulty from other researchers to try to understand well what the result was. Yes, and the result is completely not described by the current theories of gravity. So, and it was confirmed in Tohoku by a free fall experiment. It means that gravity seems to be defied a little bit in a free fall experiment, which is the standard way to measure gravity. So I'm for my PhD, as I start to collaborate with a professor of physics when I was 19 years old, I decided for my PhD to try to study a little bit to this effect, what it was. And this is where I am now. I'm still on the way with a little bit of financial researches to try to make further results ahead. So my study is not public. I did not have scholarship, so it was developed on a strictly private basis. Yes, I had to loan money from the bank, and I spent 10 years paying to the bank so that to have a Mettler-Toledo analytical balance with a precision of 0.1 milligrams and some things. So I don't know, there are many theories about this. My professor of theoretical physics who gave me support into the theoretical study, he is also specialist in Kaluza-Klein theories, like the presenter who spoke about Kaluza-Klein. And my professor said that in the Kaluza-Klein framework, it is possible by contraction of 5 dimensions into the 4 dimensions to appear a scalar field that gives rise to anti-gravity. So there are many possibilities to describe even today how can the change of gravity can happen. And I'm not a theoretical physics guy. I am just a electrotechnical engineer. So I'm just doing some experiments, and hopefully I expect in the future to publish a little bit some articles in physical review letters or other articles as I can, just to give a little bit of confirmation of the result. Yes, but I'm not in a position to give a theoretical explanation how can weight can be changed by rotation. And most strange is the symmetry of the effect is completely asymmetrical, and can be found on the internet. If anyone searches Nikolai Kozyrev and gyro in Russia in Google, he will find the result and some schematics. This is always the problem between theory and experiment. When someone claims something from the experimental side, then there is the need to find a theory that can explain it. So, as I'm not a theoretical person, I cannot go too much into the theoretical things. I just have some milligrams, and I'm planning to do experiments to do a little bit more, but I will stay on the research side. Yes. Well, so I cannot claim, or I cannot forecast that gyroscopes will bring anti-gravity or things like this. I'm just taking small steps to make some measurements and publish some articles.
Wonderful. Well, Nuno, thank you. And actually, we'd probably love to have you back on to present if you'd be open to that.
Later on, when my article will be published, because at the moment, like Rob said, I'm working with a lot of financial difficulties, so things are very. But I give you an example. I just ordered some electromagnets from China 45 days ago. And I contacted the seller some days ago to ask where they are, and they said the package was lost. So things are not easy to do things on the ship. Yes.
Awesome. Okay. Well, thank you.
Okay. Many greetings to you, and congratulations to your program.
Thank you again, sir.
Okay. Thank you very much.
Okay. Well, Rob, I think that's just about it. We've got about 1 minute left. Does anybody have any last minute questions for Rob, or? So I think we're just about set there. So again, let me do this. I want to put this on gallery view. Everyone, please put your hands together for Rob Chambers. Sir, thank you so much for a tremendous comprehensive presentation. So let's
go too fast.
let's move along now. Actually, I see a couple of hands coming up, but we're a little bit, we're running behind on time. So let me see. Yeah, I think
in the chat, I can respond in the chat.
Okay, yeah. Oh, those are applause. Okay. Okay, so let me go.